talk about the counting principle. In this section, they also talk about the tree diagram, which is basically how they prove that the counting principle actually is a principle. Okay, that actually is a rule that is true. I'm not going to spend a lot of time talking about the tree diagram, just simply because it's easier and faster to use the counting principle. And real honestly, if you made a tree diagram on most of this stuff, it would take you a while. But I do want to cover it because there are a couple of problems that they want you to draw a tree diagram. Now, let's just take, for example, our flipping the coin. Okay, we talked about that yesterday, and then it was also in your homework last night. But if we flipped a coin, let's say we're going to flip a quarter twice. Okay, and we want to know the possible outcomes, how many possible outcomes there are when we flip a coin twice. Okay, so first of all, we need to know on the first toss, what are the possible outcomes? No, I want to know what the actual outcomes are. No, listen to what I'm saying. When I flip a quarter, 1 over 2 is not going to come up. Thank you. Heads or tails is what is going to happen when I flip it once. Now, when I flip it the second time, I could either land on, in other words, I land on heads the first time, then the second time I flip it, I either land on heads or tails. Okay? Same thing here. A head or... So, you're basically either going to get a head and a head, or a head and a tail, okay? Or then you're going to get tails and a head, or tails and a tails. Okay, that's what you're going to get. So the possible outcomes are head and a head and a tails and a head, and a tails and a tails. Okay, so there's 1, 2, 3, 4 possible outcomes. Okay, and that's what this tells you right here. We have 4 possible outcomes. A head on the first one, head on the second one, head on the first one, tails on the second one. Tails on the first one, heads on the second one, tails on the first one, tails on the second one. Okay, now what the counting principle does is this. The counting principle takes, for example, the tree diagram, and this is a tree diagram. Okay, what the counting principle does is take the tree diagram and basically compact it into a mathematical principle. Okay, and the mathematical principle is this. You take the number of outcomes, of possible outcomes, for each situation, and multiply them together for the total outcomes. Okay? So if we use our flipping the coin or flipping the quarter, we have the first toss for each situation, and multiply them together for the total outcomes. So for the first toss, we had 2 possible outcomes, right? Heads and tails. For the second toss, we have 2 possible outcomes. So that's our situations. It's flipping the coin twice. So we take the outcomes and multiply them. And that means there's 4 possible, or 4 total outcomes. Okay, so you don't have to do a big tree diagram. You don't have to do any of that to get what you need. Now, where they're going to use this is, for example, let's say I am rolling 2 dice. Okay, just regular dice you would use, in a board game. I'm going to roll 2 dice, and I want to know what is the probability, or what is the number of outcomes that can come from the 2 dice. Okay, so for the first dice, on a regular dice, how many numbers are there? 6. So it's 1 to 6, so that's 6 numbers. On the second dice, you're going to have the same thing. You're going to have 1 to 6 and 6 numbers. So for the total possible outcomes, you're going to take 6 times 6, which is 36. So now that's not the probability. Okay, that's not the probability. That's basically how many outcomes you could have rolling the 2 dice. So you can see that if, for example, if we looked at a small tree diagram, okay, and you don't have to draw this tree diagram. This is the first dice and the second dice. Okay, well, you can understand that if I roll 1 dice, I'll get a 1. Well, on the second dice, I can get 1, 2, 3, 4, 5, 6. So you can see right away that it wouldn't be real plausible to do a tree diagram on things, and that's a small sampling of numbers. I mean, that would be huge. You would have to try to find out, what the actual answer is. That's why they came up with the counting principle, is to take things of that nature and be able to reduce them down to something that's a little bit easier to find how many possible outcomes there are. Okay. So, for example, then, if I had 4 shirts and 3 pair of pants, okay, how many outfits are possible out of that? How many outfits are possible out of that combination of items? Really? 3. 12. Well, because you could, look at it this way. Let's just write it out. If I had shirts, let's say I had a red one, a blue one, yellow one, and pink one. And then I had pants. I had jeans, slacks, what? Jogger. Okay. Now, see, here's the problem you've got. This is why there's so many different combinations. Okay? You could put the red with all 3 of those. So there's 3 right there. Okay? I could put the blue with all 3. So there's 3 more, which would be 6. Same thing with yellow. There's 9. Same thing with pink. There's 12. But all you have to do is take the number of shirts 4 and the number of shirts number of pants 3, multiply them together to get the 12 different combinations. No. Yeah, that's pretty hilarious. You need to go to a comedy theater and build somebody's ego up. You okay, Josh?
Yeah, I'm yawning. Don't say that I'm yawning.
All right, now let's talk about locker combinations. Okay. On your locker, you have a dial that goes from 0 to 49. Okay? Now, I know some of you are going to say that's 49 numbers, but it's not. It's 50. Okay? There's 50 numbers that are possible on your locker. All right? Now, each of those numbers can repeat. There's 3 combinations. So the first number of your combination, there's 50 choices. The second number of your combination, there's still 50 choices. And on the third number, there's 50 choices. So basic, because that would be 51 numbers. No, stop. If you count from 1 to 49, how many numbers are there? So if I add 0 to that, how many numbers do I have? See what you are doing, and it's a common mistake. You're subtracting them. You're saying 49 minus 0, that's only 49 numbers. No, that's like when we do problems 10 to 20. Okay, 10 to 20 is 11 problems, not 10. Because you got 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. What, my fingers don't do the same as yours? You going to use your toes as well? Are you wiggling your toes in your shoes going? All right, so to find out how many combination possibilities there are on your one locker, okay, you would simply take 50 times 50 times 50. Huh? Because you have 3 numbers in your combination that you've been doing all year. Huh? Because that's not the counting principle. You have 50 times 50, which is 2,500, times 50. So I just bring down the 0, 0, 0, 5. So 125,000 possible combinations on your locker. So if we wanted to take this a step further, and let's say we're going to take Copeland out, put him at one of the lockers, and say, guess the combination. Okay? Well, the probability then to guess or do the right combination on one try, obviously, would be 1 over 125,000. Almost dropped it. That wouldn't have been good. Okay? So, basically, it's sort of like we talked about yesterday when we talked about the lottery. I mean, if we lined up 125,000 people out here at the school, and each one of them got a guess at the combination, one of them might actually guess it right. Okay? Or, better yet, if we took, all the people of Fort Worth and said, hey, come by Calvary and guess the combination on this lock. Well, there's a good chance somebody eventually would guess it. Okay? It'd be just like you. If I told you to hit that car on that poster over there with a dart, and I gave you one dart, well, you're probably not going to do it. Okay? But if I gave you 20,000 darts to throw at it, eventually you're probably going to hit it. Okay? So you throw enough stuff at it, and eventually, it probably is going to come true. But that would be the possible combinations. Okay? So let's look at now. Let's look at number 8. Number Number 8 says a music store manager wants to arrange the store's merchandise into different sections. The manager wants to put CDs, tapes, and singles in different sections. Okay? So CDs, tapes, and singles, obviously, this book was written a while back. So that's the 3 sections that he wants to have. CDs, tapes, and singles. Each section will be divided into different genres: rock, R&B, rap, classical, international, and country. So, as if we look at this, we divided it into rock, R&B, rap, classical, international, music, international music, and country. All right. Now, once again, sorry means that you're actually sorry for the behavior and you stop it. Not that it means, what did you just ask me?
Is international AM?
What did you just ask? What did you ask?
I said, what does international music mean?
Okay, what's the word international mean?
Everything.
Worldwide, like music from India, China, Japan, that would be international. Okay, going from Johnson County to Tarrant County is not international. Okay? Hey. Now, so if we look at this, in your first one, there's three choices. In the second one, there's 1, 2, 3, 4, 5, 6 choices. So, to find out how many possible combinations or outcomes there is, we simply take 3 times 6, and so there's 18 possible divisions. Okay? So you're basically just taking and applying the counting principle to each of the situations that they've given you. Okay? Let's look down at number 11. Let's look at number 11. It says, using the counting principle to find the total number of possible outcomes, then determine the probability of a specified event. Each spinner is divided into equal parts. So the first one says, you spin a... First one says, number 11 says, you spin spinner A 2 times. Find the probability that it stops on 1 and then 2. Okay? So first of all, you're going to spin spinner A 2 times. I mean, we can stop and I can turn you loose. If you look at spinner A has 5 numbers on it. And each of the sections is divided into an equal part. So I have 5 sections. So I'm going to spin first time, and I got 5 numbers that could come up. I'm going to spin it the second time, and I have 5 more. The same 5 numbers could come up. So this is equal to the total outcomes of 25. Now, what they want us to do is take that information, plug it into our probability formula, and find out what is the probability that I'm going to land on a 1 and then a 2 in the second one. Okay? So they want the probability of 1 and 2 in the 2 spins. Would anything else work? No. So there's only one favorable outcome. So remember, it's favorable outcomes over total outcomes. which means that is equal to 1 over 25. Right, Copeland? Okay, so that's 1 over 25. And that's your probability that you spin the spinner, land on a 1, spin the spinner again, land on a 2. Okay, because there's only one possible outcome there. Now, so you have to have two answers there, the 25 and the 1 over 25.
What about the rest of them?
What do you mean the rest of them?
The 11 through 14.
Okay, we just did 11.
I am.
So what is your question on 11?
No, there's nothing question on it. I just don't get it.
You don't get what? You don't understand how to multiply 5 times 5?
That's all you do? Because the B, it says 4 on 4.
Okay, we're not on spinner B. We're on spinner A. Said you're spinning spinner A twice. You spin spinner A once, and there's 5 choices. You spin spinner A again, and there's 5 choices. Hey. Hey. After you scooted back. No. Don't lie. I sat there and watched you do it. Number 13. Number 13 says you spin each spinner once. Find the probability that both spinners stop on the same number. Okay? So first one, the first spinner is A. There's 5 choices there. The second spinner is B, and there's 4 choices there. So the total number of outcomes would be 4 times 5, which is 20. Now, if I spin spinner A, there's one number for each one, right? So I could land on a 1. I could land on a 2 on both spinners, okay? So there's only 2 favorable outcomes, okay? I land on a 1 here, land on a 1 here. That's all I can land on, okay? And so we want to say that there's 2, so I'm spinning one spinner, and I'm spinning the other spinner. There's 2 favorable outcomes, so I'm spinning 2 spinners. That's where the 2 comes from. I could land on a 1 and a 1. I could land on a 2 and a 2. I could land on a 3 and a 3. I could land on a 4 and a 4. Okay, so that's 2 over 20. Okay, is there any other possible? Okay, is there any possible other? Hang on, let me phrase this properly. How many numbers are there on each spinner that are the same? 4.
1, 2, 3, 4.
Okay, so there's 4 possible outcomes. So you need to change that to 4. Okay, because there's 4 different numbers that are the same on each spinner. Okay, so 4 over 20 reduces to what? 1 over 5. So the probability is 1 over 5, and the total outcomes was 20. You got to have both answers. They want the total outcomes, and they want you to figure out the probability of that. Okay? All right, let's look at number 9. I'm looking at what I want to do. 9 is the same thing that we were doing on all the others. It's just they just want to count up the number of possible.